Hi, this is class 221B, group 6. We are going to start with our discussion of our final project. So I am going to share screen the...
I think as long as we do a study without a survey, we'll be good.
Yeah. So I'm going to send them a message on when we upload a video and just ask to make sure it's only designed to study, not the other 2 sections. But you should be able to find them back in a sec. So starting with it looks like everyone's on here. Just go ahead if you can write your name. I'm using the first right left, and so just feel free to do somewhere else.
It works.
All right. The first thing we need to figure out is who wants to do what. Like I mentioned, the Davis. I'm going to be a little up in there next week. The meetings will happen. Everything will be fine. It's just that I'm going to be probably from a Starbucks next Wednesday. This assignment design to studies due Saturday. So whoever does this has to make sure we get everything done in a couple days. So I would prefer not to do the writing for design to study because I am trying to do work ahead from next week. I don't, but if you need to, I can.
Let's see.
Basically, the writer for design to study, all you're doing is this sheet right here, uploading and making sure everything's correct with the group. So we're doing it to Google Docs. So we have to have a main writer, but
I can do that.
it's really not that hard.
Yeah.
And by the way, when we do our PowerPoint presentation, I'm going to make a Google Slides that we can also use as well.
Got it.
So again, step 2 will start after you get approval in 2 weeks. So like the 3rd or 4th week of March. Who wants to do that? I can do that if you want, or I can do the PowerPoint because I am planning on doing that anyway.
Yeah, I can do whatever. I can do. Well, I guess if you do the PowerPoint, that might kind of go well with the PowerPoint. So.
Yeah, I'm gonna do the PowerPoint because I was gonna make a Google Slides, and since I'm the owner, I can. I mean, if that's okay with you guys.
Yeah, I can do this one here.
All right, cool. You okay with that, Spencer?
I'm good.
All right. This is pretty easy. What everyone can type in. Here's the real heart of the thing. We got to make sure we have a research question that we've all agreed on. So at this point in the meeting, why don't we just take turns to give out what we have ideas. I mentioned earlier I was thinking about doing gas prices in 3 different states. So we have 2 people in Idaho, 1 person in Utah, I'm in Texas. We could essentially compare our local area where we get gas, whether there's any difference between the areas or not. That's my idea. Spencer said something about the NBA. You want to?
The average height in the NBA is 6 feet 7 inches. So do players taller than 6 feet 7 inches score more points than those that are shorter than 6 feet 7 inches?
That'd be interesting. Camden, I know you had a couple ideas when we met yesterday.
Yeah, I think that gas prices would be good, and I also was thinking about just because I always pay attention to politics and things like that. There's a lot of attention with like gun violence and things like that. So I was thinking of you can find all the statistics on the CDC like government website just about how many deaths there are by gun violence in every state, and then you can easily compare that to how much like the gun ownership rate in each of those states. So that was just kind of an idea. But
that was a good idea.
Yeah. So I like that idea, and it'll be cool. One thing we need to make sure is that we have a statistical method we're using. So, so if we're looking, that would be quantitative. Which one would you want to do? If you're doing 3 or more samples, it has to be a no, comparing differences in states. So comparing one of those ideas, whether gun ownership or gun violence, is different states. If you're doing something like paired or independent, you could with 2 samples, you could look at essentially it'd probably be one area. You have 2 separate ideas you're looking at. So if you want to do like gun violence in states, you can do that would probably be more of a NOVA. You're looking at the comparison with gun violence and gun ownership. That would probably be a paired sample or independent sample in one state only.
Yeah.
Which one would be easier to do a simple random sample though?
I think that that's kind of where it gets a little bit tricky. I think just like there's ways that you can make those comparisons, like between gun ownership level and the death rate, and then compare them between several states, which would be a little bit more insightful. But if we were only to do it like with one state, it wouldn't be very insightful. So I think we'd be kind of limited for the scope of this class to do that. So maybe it'd be better to not do guns and do something maybe like the basketball, or I think gas prices would even be easy too.
I still think the guns would be a good idea. But...
What do you have something to say, Davis?
I totally agree. I think the gas prices or the NBA one would be a lot more simple and easier to kind of do.
Well, here's the thing, Camden. I would be cool doing the gun stuff, but you'd probably have to pick one or the other in terms for this class because it's a little simple statistic. What do you want to do? Look at it. So we could do a comparison, a NOVA chart of does gun violence vary in state, or we could do a sample comparison between gun violence and stuff at one state. If you want to do it, it'd probably be easier to just compare gun violence in states and see if there's a difference in states. That would be insightful. But if that's not what you're looking for, we can try something else.
Well, would it make sense to just do a paired sample and have several states, right? And then like of those states, all you have to do is just look at the gun ownership per 100,000 people and then deaths by gun per 100,000 people, and then just do pairs. And you could do as many states as you want. You just have to pair them all up. Would that make sense?
Yeah.
I think that makes sense.
So if I'm getting what you're saying, it's almost looking at 2 separate things, several different pair samples, and maybe an overall NOVA chart with all of the different states. Is that what you're looking at?
I was thinking you could just do it in one, just doing like a paired T, and in one column would be the gun. Well, is that right? No, you can't do that, can you, the paired T? Paired
T is only 2 samples, and you're talking about 2 different statistics. So you could do a paired sample between the 2 different statistics, but if you're trying to add in different locations, that's adding a third sort of plane to it, and you're going to have to the state thing would be more of an ANOVA. So you could do technically a paired T ANOVA, but I don't think we've got to that point yet where we can do that because it's probably different statistics. I like the idea, but I think it would be probably better off either picking one or doing something other than that. It makes sense.
Yeah, and what I was saying earlier is I think that if we were to just pick one, which it sounds like statistically we would have to do for the scope of this class, it just would not be very insightful simply saying Idaho has this many gun deaths, and like this, that, and the other. It's like it wouldn't really say anything. So it'd probably be a little bit more boring doing gas prices, but I think that'd be a little bit more clear. So
I agree. So do we want to do gas prices then?
Let's do gas prices. Let's do
That's fine.
All right. That's cool with me. So here's what I'm saying. So who wants to write so you're doing this, Davis, right? Why don't you write out the research question here?
I have a quick question. How will we do the simple random sampling that comes with this gas prices thing?
You could just get a list. What you could do is just get a list. So we can come up with a number of gas stations that we want to get data from, and then we can each get a list of gas stations in our area.
Yeah.
And then put them in a list, put them in a random sampler, and it'll pull up let's say we do 10. It'll come up with 10 random gas stations, and then we'll just go to those and figure out the prices.
Yeah, what I'm thinking is, what I completely agree. So what we need to do when we decide on this is how many gas stations you want to look at in each area, and then we just basically pull on Google gas stations, and you can get a list of that. Take those, and then you'd want to take a random sampler. So number those lists on like a Word document. Take a random sampler. Take those individual numbers from the random sampler. So you might want to even get like a list of 30 or 40 gas stations and narrow it down from there. That makes sense.
Yeah. We'll have to decide, on how many we want to take from each area.
Yeah.
And go that from there. But
yeah, it's possible, and it's actually not that hard.
Yeah.
All right.
So what do we want our research question to be? Like, so what are we looking at? Are gas prices higher in a certain area, or are we looking at gas prices differ?
I think it's do they differ, because ANOVA is looking at for difference between means. So if we're looking at mean gas prices in different areas, do gas prices differ between states or something like that?
Let's make it more narrow, because we're not going to be able to say, oh, they differ between states just from 3 different states. Maybe we should write like differ between, I don't know, the 3 states.
Well, because I was thinking we could do Idaho, Utah, and Texas because we live there, but we can change it up easily.
Yeah. I totally agree with that.
Yeah, no, I see your problem. Is how do you want to write it? And we have some ideas.
See how the book writes that question.
Yeah, I'm gonna look at the email that he sent us that has the ideas and see how they.
Okay, that's a good idea. If you want, you can share screen that.
Okay, yeah, that's okay.
Question. This is a quantitative study, right?
Yeah.
Okay, good.
I believe we're going to be doing a ANOVA, if that's correct.
Yeah.
And here's the thing: the minimum is 3. If you want to do more, I mean, we don't have to do all 50 states. But if you want to look at, say, Texas is sort of south, we could do pick one of Idaho or Utah for mountain. We take one western state, one Midwest, something like that, and we could get like a sample of 5 or 6 states and have more of a variance to depend on area in the U.S. That makes sense.
That would make sense.
I like to keep it simple.
Go ahead.
I always like to keep it simple.
Yeah, that's true too.
Let's not overwork ourselves here. Or maybe we should overwork ourselves and get an A.
Yeah. Yeah, so
this is funny. This one's funny. Is there a difference in the proportion of longer words, longer than 6 letters in Trump speeches versus Obama speeches? I would be curious to see that. That would be very funny.
All right, so
okay, are gas prices the same in different parts of the country? ANOVA is used.
That's where I got it.
Cool.
So it's right here.
So our gas price is the same in different parts of the country. Perfect.
And it says different parts of the country. The question is, do you want to have Idaho, Utah, and Texas and keep the 3 where we're living? Or would you like to I mean, we can still do 3, but I feel like Idaho and Utah might be similar because they're right next to each other.
I'll do Nevada. I'm only like 20 minutes away from Mesquite, Nevada. Okay.
Nevada, Idaho.
Well, technically, Nevada is not that much further. I would say Utah is fine.
Yeah.
The only suggestion I would have is maybe changing it based off of either population, or we could have one coming from the coast, because there tends to be a bigger difference coast than there is in, like, you know.
Yeah.
That's a good idea. Why don't we do Idaho would be good to do, because that's and Texas again is going to be different. I think Texas is going to be different than Idaho because it's a bigger population, different areas. Why don't we confine it to Idaho, Texas, and like California or something?
Oh, okay.
And what we can even do is define it to a city. So like big cities, Boise, Dallas, and like San Francisco, and see there's price between those big cities.
Or we can do the capitals.
Capitals, that makes sense. So Austin, Boise, and what's the capital?
California is
Sacramento.
Right?
Okay, that's cool with me if you want to do that then.
California's gonna be an outlier, man. That place is so expensive to live.
But I think that would be good though.
Yeah.
Because if you're trying to compare across the state and you don't include something that has the potential to be an outlier.
Since there are 4 of us, should we do 4 different states?
Yeah, that makes sense. We each get a state data.
So let's do one over like in the east.
Rhode Island.
What about Washington, D.C.? Not a state, but it might have, or New York City. New York City would be interesting.
Yeah, that'd be pretty good.
So I'm gonna do Dallas, Texas, or Austin, or I'll pick some city in Texas. I haven't decided which, but I'll do one of those. If you guys just want to each pick a city, and then this will commute about which one we're doing.
In New York City, the gas is on average $4.40 right now, so that'd be some good motivation there.
Man, that's expensive.
It used to be like that here in Boise, though. I'll do Boise since I used to live there.
So I'll probably do Dallas, because Dallas-Fort Worth Metroplex has a huge variation between places. So trying to find doing the mean of those would be interesting.
Yeah, and we'll need to make sure, like I said, we come up with the certain number of gas stations we're looking, like brands of gas stations we're looking at.
Yeah. Well, here's the question. If we're trying to do a simple random sample of each area, what do you want to get, like a list of as many as possible and then select it from there? Because I feel like the bigger our list that we randomly select from, the more chance of it being a normal distribution.
Exactly, yeah.
So we need to at least have, no, I don't want to say we need to have 30 samples, but we need something that's large enough we can figure out if it's, that makes sense.
I think we can talk about that later. Let's just answer these questions now.
Okay, yeah, that's cool. Sorry.
No, you're good. You're good.
All right. So, what populations are we studying? That would be.
Crap.
Yeah, it's kind of confusing.
Okay, so what are the populations we're studying?
Hey, just a thought. I know I'm sorry for being picky. Do you guys think that on this part here, on the number 1, if we should just change that to be between the capitals of the U.S., because that would be the population, and then our samples would be these 4 cities.
That's true. Yeah.
That makes sense to me.
Good.
No.
And actually, in that case, then it pretty much predetermines what we get. So Idaho would be Boise, Texas would be Austin, New York. It wouldn't be New York City though, would it?
No, the capital is
Albany.
Yeah.
Albany. That's not New York City.
That's still fine. I like the idea of looking at capitals.
Perfect. No, that makes a lot more sense.
Yeah, and it's a little more clear about what we're looking at.
Yeah, I agree.
Okay, perfect. So what is your experimental unit? In other words, what is the smallest entity from which you are collecting a single piece of data to be used for analysis?
The 1 gas station, right?
Yeah. So 1 gas station.
Yeah.
Oh my gosh. Okay. What is response variable? Gas prices, right?
Yeah. We're seeing if gas prices vary by capital.
Is it
In a while since I've heard those terms.
Is the response variable quantitative or categorical? Quantitative.
Yeah.
Oh, not quantitative.
Sorry, that was funny.
And it'd be a Nova.
Yeah.
I'll just highlight that. Let's see.
There should be a highlight button up at the top.
I'll just try to text. No, that does not look good.
That's maybe a different color. There should be a way to change the color of it. There you go.
Okay. So, what are your null and alternative hypotheses? So, the null hypothesis would be there is no change, right?
Well, wouldn't the null be like a number, like or me over? I don't know.
The null would be mu equals 0.
Yeah.
Okay, so how do I write that? Because it's like H.
H-O.
Just H-O.
Or,
H-0.
I don't know.
I don't know what I'm doing.
I'll look it up.
I think there's a way, but it's like it's like mathematics script, so I don't know where the tools would be on this.
That's fine. I'll just do that. I think they'll know what I'm talking about.
Yeah, and if we need to change it, he will let us know. So
U equals
0.
Wait. How did we do the hypothesis, the null hypothesis for ANOVA? I feel like it was different. You know what I'm saying?
Well, it's comparing all. There should be a null. I'm gonna pull it up my textbook.
Okay.
That makes sense.
Because I know the alternative hypothesis is going to be like something about like there's a change or one or more of the I don't know, one or more of the data or whatever are different.
Yeah, I'm bringing it up right now. Hopefully this is share screen.
Hey, there you go. How'd you do that?
Copy and paste, baby.
So is this H no all the means are equal?
Yeah. But I don't think it was in words, was it?
That's what I'm trying to figure out.
Oh, maybe it was.
No, I think it was. Here it is, the work example. You see this?
Yeah.
I think that's what we're looking for.
And then what was the alternative hypothesis?
At least one that means differs. So my money's on either California or New York.
Yeah, for sure. I would say all of them differ, but to be honest.
Yeah, I would think they would differ depending on where you're getting the gas from. But like Texas may be lower because we have refineries in Texas.
Mm-hmm.
But it also I would not we're gonna do that, but I would be interested on my own if we compare it like in cities in one state would also be pretty interesting too.
That would be interesting because I guarantee it'd be different within states also.
Yeah, because like Texas, yeah, there's probably you give Texas is big, it has a lot of population. There's probably different. California the same, but I wouldn't know if somebody like Utah would be different though either. Yeah,
because I know it's like it differs between Boise and here quite a bit actually.
Yeah.
Usually, so.
Well, like when we drive down from Dallas to Houston to visit my grandfather, we often the Dallas prices often are at least 30 cents more than some of the rural like highway stations. And if you go off the highway to like a rural town, it's often very far less.
Yeah. All right. So are we done with that?
Yeah. Let me check. That looks good to me. I will send him in. I will send a message on our video meeting. Just ask to make sure it's only that section.
Because why weren't we doing the design the sample again?
That's what I'm not sure.
But
you want to go? You want to go ahead and do that now?
Well, we'd probably be able to do 8 through 12, but we wouldn't have to do 13 through.
Yeah. I'm gonna.
14 because we're not doing surveys.
Okay. Hey guys, my dad just let me know there's an easy way to do this. So there's a app called Gas Buddy. I showed you. So there, I don't know if you can see it. It's an app called Gas Buddy. It lets you find gas prices the best. So it shows you variation in gas prices around areas near you, and you can change the location too.
Sweet.
I'm getting that right now.
I say let's move on to the quiz and do that. I have to go, and then as soon as we find out what we have to do, I mean, we could always meet again and do it if we need to.
So this week is fairly open for me. I will send him an email or make a message on the video link when I upload and make sure he somehow gets in. We have a question about that.
Because we can talk about it on Thursday or whenever we meet again too, because it's not due till Saturday. So
since we met Tuesday, do you want to meet Thursday then?
That works for me.
Give us 2 days to get some stuff ready. All right, let's get the quiz real quick, and so Davis can go work.
So who's going to turn this in?
I will.
Davis, you should be able to download it, Davis. From here, you have rights if you don't let me know. Basically, it's under file. There's a way to download, and you can email or send it up on that.
Sweet. Sounds good.
I love Google Docs.
Yeah, it's super nice. And it's due Saturday, right?
It is due Saturday at the end of Saturday. So if we meet Thursday and it looks like we're going to need some more time, we can always meet Friday or Saturday morning. Anyway, I can't do Saturday because I'm going to be driving to Austin.
That's fine. We'll figure it out.
We'll have it done before Friday, I believe.
Yeah.
All right. We ready for this then?
Yep.
Want me to read question 3?
Yes.
In a pie chart, why are the slices sector different sizes?
I like the last one.
That's great.
Oh my gosh.
It's gotta be C. It's gotta be D.
I would say C.
Yeah, that makes sense to me. Some of these answers, these responses though, are pretty funny.
This next one's C.
Yeah.
All right. So use the following information for the next 3 questions. We conclude that the proportion of P is normally distributed. NP is greater than or equal to 10, and N1 minus P is greater than or equal to 10. So is P the true proportion or the sample proportion?
It's true, right? P hat is the sample and regular P is true, right?
That's right. I forgot about that. I had written that down. I don't have it in front of me. Is that really what it's called, P hat? Because that's what I was calling. That's what I was saying in my name.
That's what I said in the video. It was P hat. So I'm gonna go with the math instructor.
All right. So this.
Yeah, the sample proportion is P hat. So I would say it's true, the true proportion.
Okay.
That's what I have in my notes.
Yeah, that's what I got too. It's on the that's what I got from the video. Ready to move on then? Question 6.
Yeah.
Yep.
All right. What is N?
Sample size.
Yeah, that's like. Okay, this one's interesting. If P equals 1/4, what are the smallest N that satisfies the requirement?
Okay, so I think this might be where I kind of got screwed up.
Because you got to reverse engineer it essentially. Plug that number in. So look into the formulas up where you see where it says P hat, NP is greater than 10, and N times 1 minus P. You got to plug in the P and to define the N. Does that make sense?
Mm-hmm.
Okay.
So if P is 1/4, then.
Okay, so.
It's 2.5.
Would it be, okay. What do you get for the first one? I got 40.
Wait, so. N times.
I guess that's not right.
N times 1/4 is greater than or equal to 10, right?
Yeah.
Okay.
So I think it would have to be 40 because for the first one, anything less than 40 is not going to be.
Yeah, 40.
Oh, sorry. I multiplied it. I didn't do divide. That's why it's 40, not 2.5.
And you could do it with either one.
Yeah. Right? You'd have to satisfy both, but normally it's. Sorry, I read that wrong. 40.
Yeah, it just depends on how much work you want to do.
Yeah. All right. You ready then for the next question?
Yeah.
All right. Use the following information to answer the next two questions. Suppose n equals 24 and p equals 0.4. What is the mean of p?
Okay.
That's 0.4, right? Because p hat is the same as p.
Is it?
I'm.
Or is it p hat? Oh, that's the standard deviation. P hat equals.
We're looking at the mean.
Is it 9.6?
Give me 1 second. I'm gonna pull it up. And here.
Yeah, I guess this is where I get confused. Like.
Where is it? It's here. Right? The sum of p is normally distributed if n is large. Mean of p hat equals p.
Oh. Okay. There you go. So 0.4.
Now I think we're getting the standard deviation of p hat. So this is where we use this formula of p times 1 minus p over n square root of the whole thing.
Makes sense. Okay. Square root of 0.4. 0.4 over, what was n again? 24.
I got 0.1.
Right.
Yep, 0.01.
Did I do it wrong then? Double check my work.
Did you, Camden? I don't think you took the square root.
Oh gosh, yeah, you're right.
Okay, because I couldn't.
Yeah, the biggest symbol in that entire equation, or formula rather. And I did
Yeah, that will definitely get the wrong answer if you don't do that. All right, 0.1
So
then.
this next one is going to be 0.3 is going to be 10. Yeah.
So 10, we ready?
Yes.
So p hat is equal to p, so 0.3. I think you said that right, Camden.
Yeah.
All right, 11. Let's do standard deviation, and we'll check when we get together. Let's see. Let's see.
I don't know what to do for the standard deviation. I'm drawing a blank.
The same as this last one.
Yeah.
Wait. So like it would be the whole p hat equals the square root of p times 1 minus p over n.
So just FYI, this is what I'm doing when I'm putting into calculator. I'm doing the square root sign, it drops the parentheses, put a second parentheses in our 0.3 times parentheses 1 minus 0.3 in the parentheses divided by 100 in the second parentheses. And I have to end one more after that. The parentheses are what's going to kill you here if you do it on a calculator. You get that wrong, it won't even give you the answer.
Yeah. I mean,
So I mean,
go ahead.
0.046.
Same here. That's what I got. You doing okay, Spencer?
Yep.
All right. Now we're on z-score. Let me pull this up, the formula, so we can all have to look at right here. You see that?
P hat minus P
over standard deviation of P hat.
Yeah.
All right, let me. I'm gonna leave that up so we can look at the formula. Okay.
Sweet.
Let me just get value over here.
Okay, so it's gonna be P hat, so 0.
This is what I'm trying to figure out. What is our P hat? Because aren't they the same?
0.046. Because we're just
okay.
getting the score of this last. Oh wait, no, it's because it's not the standard deviation. It's
it's the P value. This is what I'm confused. I maybe we did 10 wrong.
That's what I was thinking because it's just a round to 2 decimal places.
All right, let me check the textbook. Okay, yeah. P hat is the number of times. So it's right here. It's P hat equals X over N.
So the mean of P hat is equal to P, right? But yes, okay. But then P hat is different.
Yeah.
P hat is X over N.
Yeah.
Okay. Wait, what's X though?
X would it be 35 until 0.35?
Or was it 0.3?
Because it's 35 in the next 100, so that would be 0.35 what the P.
Oh.
So probably 10 is 0.35. Maybe.
So it's...
Yeah, that's it. Because 35 is the number we're looking for. Over 10, that's 0.35.
So it's 35 over 100.
Yeah.
So it's 0.35.
So 10 is 0.35. 11 might be different because we need to make sure we're using. All right.
That should be fine.
Okay, 11's fine because it's using the same as using the population P. It's not P hat. So it's 0.046. And then these score, we just plug in that stuff. So all right, you guys got these scores ready to share? Need just a sec.
Not quite.
All right.
I'm confused at how I'm going to do this all on my calculator.
I did in 2 chunks. So I did a top chunk and then that answer divided by my second chunk. You can also do what I've done before where you do each section and then save it as an alpha number and then just divide it to alpha numbers. That makes sense?
Yeah.
So
so what'd you get, Brooks?
1.091.
I got 1.09 or 1.087.
That's what I got.
All right, let me check if I did it wrong.
Maybe there was an error in rounding. I don't know.
Yeah, because I never rounded. I just kept the infinite in my calculator.
I'm gonna go with you guys. I think I did a rounding error. So
1.086.
Yeah.
Or 87, right?
Yeah, 87.
Yeah, I rounded it. That's my bad.
Okay.
And then this 13 is just looking at the normal probability applet.
So you just put in 1.087 to the applet.
Yeah.
I don't have that open. Does someone else have that?
I got it up here.
Yeah.
And then we are looking, let's figure out what we're looking for shading wise. At least. So we're
everything below.
no. At least means everything above, right?
Yeah.
So that right?
Yep. So
0.1389.
139. Yeah, because it's the 3. All right, everyone have those ready to move on?
Yep.
All right. If the true proportion of people who support a political candidate is P equals 0.52 and N equals 2,000 people are surveyed, we want to determine the probability the results of the survey will suggest a candidate is losing the election in less than 50% of the votes.
Okay, so the standard deviation of P hat. So P hat equals, it's the square root of P.
Yeah.
0.52.
0.004.
What do you guys get? Okay.
Crap. So square root, parenthesis, 0.52. How'd you set this up again, Brooks?
All right. Square root brings you a natural parenthesis. You want to put a second one after that so you can have it divided by stuff. So square root, parenthesis, 0.52, parenthesis, 1 minus 0.52 in parenthesis, divided by 2,000 double in parenthesis.
1 minus 0.52.
In parenthesis.
Okay. Divided by
2,000, and you got 2 in parentheses after that.
I got 0.0111.
Same here. What do you get, Camden?
Getting 0.004. What are you guys getting for your p hat value? Is it the same as the p value?
Oh, in the standard deviation, it only uses the p value, not the p hat value.
Yeah. So it's p times 1 minus p over n.
That's what I was doing wrong. P times 1 minus p over n.
All right, we good then?
Mm-hmm.
So do you get it, Camden?
Yeah, 0.011.
Oh, 3, so 0.011. All right. Now we just convert that to z-score.
So we do need to find the p value then.
Yeah. So
or the p hat. Sorry.
P hat. So p hat is going to be 0.52. No. It'll be what we're looking for. So 50. So 0.5. Minus. No.
0.5 divided by 200.
Yeah, that's it. 2,000, right?
Or yeah, sorry. 0.5 divided by 2,000.
I don't think that's right.
I don't think that's right either.
Are you getting e to the -4?
Yeah, 2.5.
That's not.
2.5 e to the -4.
I'm thinking the p hat is
Isn't it just 0.5, 50%?
That's what I'm thinking.
Well, then why is it? But it's x divided by n.
That's what I'm not sure because.
Well, think about it.
Oh, so what we're looking at here is p hat is your
I think it might be right.
Okay. I'm thinking it's 0.5. What do you guys think?
I think it's 0.52. Oh, 0.5 as well. Sorry.
Yeah, so for the p hat, and then you take 0.5 minus 0.52.
So why would it be 0.5 then? It confuses me.
Well, because P is 0.52, he's currently leading. We're trying to figure out if he gets less than, so I'm thinking it's going to be a negative P score or Z score. But that's, feel free to jump in.
Why wouldn't it be X over N, though, to find the P?
That's what I'm not sure. So I just want to...
I'll be out a second. I don't know. I'm confused.
Yeah, I'm reading it. It's not making anything clearer. Sorry. Huh. Okay, here. Look at my screen. I pulled up the example political elections. It says here that P hat is 0.5 because that's what we're looking for, and P is 0.48. That makes sense?
I agree.
If the true proportion people support political candidates, P equals 0.48, and if N equals 1,041 people are certain, what's the probability that the candidate will win the election?
So then did we get the P hat wrong in the last one?
No, I think the P hat was right in the last one. Because it's looking at what's the probability we're looking for is P hat.
Okay. Okay.
That makes sense?
I think so.
So the probability mean we're testing and the sample is 0.5 and it's political. And then the baseball one, it was we were testing 0.35. That's what she was looking for. I'm gonna go with that. If we get it wrong, I'll be one to test this one.
So P is 0.52 because it gives us P.
Yeah, that is the sample. That is the population one. So it should be 0.5 minus 0.52. And then divided by the standard deviation. Because I am pretty confident this is the negative Z score.
Yeah.
That makes sense. And then it'd be shaded lower.
Maybe I was wrong. I made a weird Z score, like I made that wrong.
I'm getting negative 1.818.
That sounds right. Mine is like negative 8.95 e to the negative 4. That is definitely not right.
Yeah.
That's when you did something wrong.
Mine said error.
What did you get, Camden? We'll go over that.
I did 0.5 minus 0.52 over the standard deviation, which is 0.011, I'm getting a negative 1.818.
I think that's right. Is that okay with you guys?
That's fine. And if we get it wrong, it's probably just because we did it to a rounded number, and we'll just have to like extrapolate it out and do it again.
Yeah, that makes sense. So 16, what's the probability? So plug this into Apple score.
Wait, I got 1.790. Is that what you guys had?
Positive or negative?
No, negative 1.818.
Well, it would actually be negative 1.812 because the next number is an 8. So
all right.
0.812.
Wait a second. Hang on a second. Let me. Oh my gosh.
Okay. So wait, are we on 16 now?
Yeah. So right now we have negative 818.
818. It's 818.
Right.
1.818. Yes.
All right. Does someone want to double check that real quick while we work on 16? No offense, Camden. I just want to make sure we can get it. If we
No. I think that's good.
If we answers are repeatable, it's normally true.
I'll do it.
All right, cool. You work on that, Davis. I'm gonna pull up this negative 818 on the applet.
It will be 0.0345.
That's what I got too. We'll wait just a sec for Davis because I don't feel comfortable if someone can get the same answer twice. It's more likely to be true than getting different wrong answer. Yeah, all right.
I agree.
I don't know. It won't give me the answer. Keep saying error.
You may be missing a parenthesis then. It's saying syntax error?
Yeah.
Then you're probably having a
No, it's saying unreal number.
Oh, okay. What are you putting in for the square root?
What the freak? So square root parentheses 0.52 parentheses 0.52. No, 1 minus 0.52, right?
Yeah.
1 minus 0.52 end parenthesis divided by 2,000 double end parenthesis.
Yeah. I'm doing it right now. Let's see if it works.
Okay. So, and then 2 divided by.
All right, I'm getting negative 1.790.
That's what I got.
Yeah, that's what Spencer got, right?
Yep.
Yeah, that's what I got too.
All right. That okay, Camden?
Heck yeah, dude. Is it okay to get it right? Yeah.
1.79. Well.
So negative 1.790.
Yeah.
Yeah, I'll put that in now.
And when it comes to math, the majority rule is normally a good decision.
I agree.
For some reason, mine was positive, but I don't know.
My first problem was I didn't divide the 2,000. I times it by 2,000. So that was always going to be a weird score.
I'm giving the probability the final answer is 0.037.
0.037.
Is that what you're getting, Brooks?
Yeah, 0.037 because it rounds up. Okay, that's cool with me.
Okay.
All right, I'm gonna turn it in. I'll be the guinea pig this time, and we'll go back and we can change anything.
We're at 100%.
You got it?
Yeah.
All right, good job, everyone. So I will, when I submit the video, I'll make a question for the Brother Esplin and make sure he knows we would want to know if we need to do the rest of that section. And after that, and check later tonight. And if I hear back, I'll text you guys and let you know. And then plan on Thursday at 2 o'clock.
Hey, what was 14 and 15 again? I think I put my name wrong.
All right, I gotta go. See you guys.
All right, yeah, see you then. 14 is P 0.011, and 15 is negative 1.79.
Wow, I put 0.11 on 14, and on 15 I put 1.790.
Well, 14 is 0.011.
Really? Okay.
And 15 is negative.
Oh, negative. Oh.
That's probably your two errors.
Okay. Sounds good.
All right. I'm going to end the broadcast right here.